we've seen how to bring data into SAS, we're going to talk about how to analyze it. I'm going to skip over some of the graphic options that are in SAS because I think they're still a little clunky, and I usually just prefer to do a graphical analysis or visualization of my data using JUMP. So we're just going to be focusing on the statistical analysis part in JUMP. So most of our analyses that we're going to do in this class are going to be with PROC Mixed. There's another procedure out there called PROC GLM for General Linear Model, but I don't like to use PROC GLM because in some cases where you have multiple random effects, PROC GLM will not do the appropriate tests by default. So PROC Mixed can pretty much do everything PROC GLM does, plus more. So we're just going to be focusing on PROC Mixed. So this is the basic structure of PROC Mixed, and it's going to do something similar as FitModel did in JUMP. We just have to set it up in a different way. So the first thing that we need to do, using this kind of skeleton code, is tell it what data set. So here we're going to say trout. So whenever it says data, you have to do it in terms of a SAS data set. So it has to be done after you've done PROC import, which is why I have PROC import still open right here, because I had to bring that in earlier. The next statement that we need to do is we need to tell SAS which variables are categorical. So class stands for classification. So you only want to put your categorical variable names following class. So for the trout data set, let me just open that up. I only want to think of sulfamyrazine, or just sulf, as being a categorical variable. So I'm just going to type in sulf like that. If I had another variable, let's say sulf2, I would just put a space and say sulf2. But I only have one, so I'll just do sulf. For model, I need to just type out what my model looks like. So this is more similar to what we have in class. So my response in my data set is Y, so I put down a Y. If it was something else like hemoglobin, I would put down hemoglobin instead of Y. So let's just say Y is equal to sulf. Again, I don't need to say that there needs to be an intercept or there needs to be a residual error term. JUMP or SAS already knows that it's supposed to be there. So this is just how I'm going to set up my one-way Anova model in this case. Now, additional things that I can do is I can tell SAS, I want you to fit this model, but I also want you to give me all of the, let's say, Tukey pairwise comparisons. So I'm just going to leave the skeleton code as having these three options. It does a Tukey adjustment. The CL gives you confidence limits or confidence intervals, and PDIF is going to do probability of there being a difference between the pairwise. So what I type in here is the model effect that I want to do these pairwise comparisons for. So again, this is just sulf, because this is the only model effect. Additionally, I can do an individual, or I can do an overall contrast like I could in JUMP, but I have a little bit more freedom. So I could do just one contrast, and I'll just say sulf 5 minus, or I could even just say 5 minus 0, just to say that we're comparing the 5th level to the 0th level. And so the way I get this the way I tell SAS to do this analysis is then I say what model effect I'm interested in, and I need to do pluses and minuses for what I want to compare it to. So I want to make, and this is going to be in the same order as the classification for sulfur. So this order for not sulfur, sulfamyrazine is going to be 0, 5, 10, and then 15. So I'm going to put my coefficients in that order. So the 0 coefficient is going to be a -1. The 5 coefficient is going to be a 1. This is going to be a 0, and then this is going to be a 0. So let me go on ahead and run this. So I get a lot of output. Let me just make sure everything ran just fine. I don't see any errors. It says looks like PROC Mixed ran appropriately. So this is all my output that shows up in the results viewer. The first thing is it gives me just kind of overall information about the model. It says where the data was, what my dependent variable is called. This tells me what my covariance structure looks like. So we just have our residuals are all sigma squared. So it says it's a sigma squared I matrix. The estimation method, it says REML, but that doesn't really apply in this case because there's no extra random effects. And we'll worry about these extra ones later on when we start talking about subsampling and random block effects. Class level information, this is how you can verify the order of the class levels, so you know you did your contrast correctly. So this is the order that they appear in, 0, 5, 10, and 15, which we had already guessed correctly. We can ignore this, although there is some information we'll see later on contained in there. This covariance parameter estimate, we only have one, so this is going to be our estimate of sigma squared, and we saw that earlier in the jump output. We have AIC and BIC values, which we'll use later on. Here is my, do they have an overall Anova test? It looks like they don't have an overall Anova test in PROC Mixed, but here we usually use these to do our tests of the fixed effects. And so here we have 3 numerator degrees of freedom, 36 denominators degrees of freedom, and so we get very similar, exactly the same values as we had before. The contrast output, though, leaves a little bit to be a little bit more than we would probably want to see. Notice that this contrast output, all it does is it tells us what the F value is and the P value for those contrasts of being significant or not. So it actually isn't doing any sort of estimation for what those contrasts actually are. We'll have to do that with the estimate statement, which I'll show you in just a second. The LS means option starts out by giving you all the LS means, just like we had in that table in jump, and we can see that all these values match those that were found in jump. And then it tells you all of the pairwise differences. So this table is a little bit easier to read than the matrix that jump gives you. So here it tells you what the levels are that are being compared. So this is doing 0 minus 5, not 5 minus 0, which is what we were doing up here. And so the estimate is negative. If we keep scrolling across, we can see the t value is minus 3.8. Again, this is testing to see if the contrast between 0 and 5 is equal to 0 or not. And the unadjusted p-value is 0.0005. When we apply our 2-key adjustment, that p-value does get adjusted slightly and becomes a little bit larger than 0.005. And we can also see on the further right, this lower and upper, these are the unadjusted confidence intervals, and this is the adjusted confidence interval based off of the 2-key adjustment. So we can see that the lower is a little bit more negative than this one, and the upper is a little bit higher up than this one is. And we can see that being the same across all of these. So we also have different options for an adjustment in the LS means. We could also say that this is, let's say we can make a Chaffee adjustment, which is not available in jump as far as I know. So let me re-highlight this and run it again. And then these are all going to be the same, but I get slightly different adjusted lower and upper bounds and adjusted P. So these are actually going to be a little bit wider confidence intervals than the 2-key, and that's because the 2-key is specifically aimed at doing pairwise comparisons. So it's very, very powerful for pairwise comparisons. Again, the Chaffee method can be used for all sorts of contrasts, but I haven't been able to find a way to make SAS give you Chaffee adjustments for any contrast. That's something that you will actually have to figure out yourself by looking up the F value. So let's look at ways that we can come up with estimates for contrasts rather than just looking at this overall sort of test. So we're going to do this with the estimate statement. And so let me do this same comparison. Even though I had the 5 minus 0 comparison in my pairwise comparisons, let's just do this with the estimate statement. So it actually is done the exact same way as the contrast statement. So let me highlight this and select run. Again, no errors. And here is my estimate for 5 minus 0. So 2.13, this is my standard error, 36 denominator degrees of freedom. So it's exactly the same as this row right here, unadjusted, except I flipped the direction of it. So I could do other things. So I could, for example, do, I could do other coefficients like minus 0.5 and 0.5. And this is something that you can't really do in jump because it has to be -1 or +1. So I can highlight this, click run, and so here I get, it's the same sort of comparison. I've just divided everything by 2 instead of making it 1 minus 1. So I'm just showing you that this is one advantage that SAS has, is you can get a little bit more creative with the coefficients rather than being restricted to the plus and minuses clicking that you have to do in jump. One other thing that you can do with the contrast statement is you can do multiple contrast statements or multiple contrasts, which you couldn't do, which you could do in jump. The estimate statement is not capable of doing this. The estimate statement can only do one contrast at a time. So let's do the contrast statement to do all those linearly independent comparisons. So we're going to do, let's just call this 0 versus 5, 10, 15. So the way you do this is, give me 1 second. I just need to look this up real fast. So I might as well take this moment to actually show you. SAS has really good documentation. So I forgot exactly how to do multiple contrasts. So I just went on Google and typed in PROC mixed contrast. And I'm going to click on this. And it should load documentation. So they actually do go into quite a bit of detail about what it's doing theoretically in the background. And they give you some good examples about different things that you can do. So what I was confused about is how I can define multiple contrasts. So what I can see here is I can define multiple contrasts. I just need to make sure I put a comma after each one of them. So let's do that. So I apologize for forgetting how to do that. So my first contrast is going to be 0 compared to 5. So I'll put a comma. And I'm going to make my next contrast. I'm going to do sulf again. And do -1, 0, and then 1, and the last one 0. And then I'm going to do sulf -1, 0, 0, 1. So there are my 3 contrasts. And so I know that this overall test should be equivalent to, or this test of these 3 should be equivalent to my overall test. So let me highlight it and click run. So here I have 0 versus 5, 10, and 15. My overall p-value here was 0.0027. I get the same one there. And then this is 5.7. So again, what this is testing is whether these 3 contrasts are all equal to 0 simultaneously. So if any one of them is not equal to 0, then this test should reject. So hopefully I've given you kind of a good array of how PROC mixed works, some of the structure. I showed you how you can look at documentation when you forget how to do things like I did. And showed you some advantages and disadvantages of this versus jump.